So hello everyone. Thank you very much for attending the webinar today. My name is Michelle Gray, and on behalf of the Atlantic Salmon Conservation Foundation and the Canadian Rivers Institute, I would like to welcome you to today's webinar. This series is made possible in part thanks to contributions from the Government of Canada. And today we are delighted to have to be hosting Vince McMullin, who's going to be talking about data and data management, and then also showing at the end some long-awaited, or some people have been waiting for, the new aquatic data warehouse for New Brunswick, the MB Waters. A few quick housekeeping matters before we start. For those of you that are new to this series, we save all questions until the end of the presentation. To ask your question, you can use in your webinar control panel, the little gray box. If it's minimized, you can hit the orange arrow to enlarge it, but you should be able to see a virtual hand, a little orange hand or yellow hand, and raise that, and we can unmute you if you have a mic to ask the question, or if you prefer, you can type your question on the control panel, and Darla or I can read it aloud at the end of the session. Without further ado, I will turn the webinar over to Vince.
Okay, thanks a lot. So you guys can see my screen, I think?
No, we're seeing your workstation. I think you're on the other monitor.
Oh, okay. Let me just 1 second. I have to apologize. We just got the internet fast here. It's actually really windy right now here in St. John. I don't know if anybody here is from St. John, but we lost the internet here on the west side for most of the morning.
Great timing.
Yeah.
I see your workstation window.
Okay. Let's just see here.
It was up like a minute ago.
Okay. Well, let's just go ahead and try this then. Okay, can you guys see it?
Now we do. Yep, perfect.
Okay, great.
Terrific.
Can you see the talk? Okay, fantastic. All right, well, so today I'm going to be giving a presentation.
Vince, you've cut out. We're not hearing you any longer.
Well, that was fairly annoying. All right, so today we're going to be giving a presentation, one that I've done for the Canadian Water Network about a year ago. And it's called Water in the Clouds. And this is sort of playing on a bit of a pun with regards to water data and putting water data into what we traditionally know as web servers and databasing. So just to give a quick overview of the talk, I'll give a personal statement. I'll talk a little bit about my background. I'm going to be talking about some existing cloud technologies. I'm also going to get into talking about some watershed monitoring and talking about the cloud. Then I'm going to work into talking about cloud requirements, some lessons learned from my previous work, as well as some next steps and considerations. So in terms of a personal statement, I believe that we need to look at all of our data, in other words, the big picture, in order to truly understand the impacts of our collective decisions on one non-renewable resource that we simply can't live without. And that, of course, is water. In terms of my background, I've spent well over the past decade looking at issues with regards to taking water-based data, whether it be ecosystem-based health data, hydrographic data, water quality data, and putting those types of data into very large cumulative data sets that can be used for things like cumulative effects assessment. I've worked with a number of universities on this topic, from undergraduate all the way up currently to my PhD. I've worked with research councils as well as the United Nations, Environment Canada, international governments such as the Singaporean government. I've also worked with a number of institutes, including the Canadian Rivers Institute, the Canadian Water Network, which is sort of a theme with me. I've spent a number of years working with the Canadian Water Network on this particular topic, as well as the Bredor Lakes Institute in Cape Breton. So my current work right now for my PhD contributes to this sort of ongoing effort with me personally, developing a cumulative effects assessment-based framework for the St. John Harbor. With that project, one of the things that I've identified as being very important is also having a very strong database management system that can be used to collect data when myself and my colleagues are finished with our work on the St. John Harbor and we decide to go on and do other things. What we're hoping to build is a monitoring framework that can be used for many generations to come. So with that, I'd like to ask if anybody here on this call knows who the Canadian Water Network is, and do they know what the Canadian Water Network does, because this will sort of continue to be a theme throughout my talk. So I'm curious if anybody here, I don't know how that will work, Michelle, but...
So Vince, I don't think there's an easy way that we can unmute everyone.
Okay.
So perhaps maybe we can just assume that some folks do and some folks don't.
Okay. Okay. Okay, so just moving along then. I have a decent history with the Canadian Water Network. Like I said, I've worked, my master's degree was funded through CWN. My PhD, currently there's some funding coming through the CWN. And I've spent a great deal of time working on data management issues with the Canadian Water Network on a project that was funded through CWN known as THREATS. And THREATS was the Healthy River Ecosystem Assessment System. And it was a project of the University of Saskatchewan. And this particular project basically was, they were trying to bring together very large data sets from across Canada, including things like water quality, municipal waste, and a number of other large data sets to do cumulative effects assessment. And unfortunately that project is currently right now on hold, and I'm no longer working on that project, but I'm hoping that that does come back, become accessible to everybody in Canada. So this is a quick story that I've told to students before. One of the things that I've observed over the last few years is students have started to figure out, graduate students, undergraduate students, have started to figure out there are technologies out there to assist them in their everyday data mining, data collecting activities. And one of those tools is Dropbox. And so Dropbox is a tool that I'm sure everybody here is familiar with. It's a cloud-based file system that can be used to store data. And students have started using this to store data, and I've noticed that lots of professionals now have started using Dropbox as well. However, Dropbox to me is a very limited piece of software, but it does provide the idealistic atmosphere that I want to promote, and that is storing water data in the cloud, so it can be accessible for many generations and not be hidden somewhere on a floppy drive in somebody's file cabinet. So for the Canadian Water Network, I've pitched to them that they should have an official Dropbox, that they set up themselves internally a commercial-based application that they can use to collect all of their data and keep track of it. And they're actually working on that initiative now, which is really great, and they're encouraging all the watershed nodes across Canada to also look at this this technology and use it for at least collecting things like spreadsheets and access databases. why do we use a tool like Dropbox? Well, it's easy to use, installs on all computers, it's accessible, it's fairly secure in terms of data. The safety of the data is, of course, a concern. If somebody sits down at your computer, they do have access to the data on that workstation. And also data synchronizes, and this is something that a lot of professionals don't seem to realize, is that Dropbox actually keeps many different revisions of the data. Every time you save a new version of the file and it gets uploaded to Dropbox, all the old revisions are actually there, and you can go back and restore it. So, for example, if you have your, an incident and you happen to lose your data, your hard drive goes corrupt or whatever, that data is actually available, and you can go and get an older copy if you need to. It also makes it fairly easy to share data to colleagues across a network, especially in a remote environment such as the Canadian Water Network. There's individuals working for that network across Canada, and so this is a tool that makes sense for them. What Dropbox doesn't do for us is it's just a file service. So there's no way to query similar data sets. There's no way to generate reports from the service. It really much so encourages teams to work in isolation and actually fuels that, that idea. And there's no administrative control. And that's something that administrators and managers are looking for, to be able to have some upper level, upper security tiered control over the data. So another example of a cloud-based service is, of course, these two icons in the tech industry, Facebook and Twitter. I'm sure everybody here on the channel has heard of Facebook and Twitter by now. If you haven't, you've definitely been under a rock. With Facebook, they've been developing some technologies recently, such as this face graph search tool. And this is something that was announced late last year. And so with face graph, similar interests of people are able to share those across a network. So you have a network of people and they have a similar interest. The idea behind Facebook is that you can come along and you can type somebody's name and an interest, or just an interest, and find somebody in your network that has the same interests. How this is working in the back end is very similar to how we envision developing environment tools for people to do things like monitoring. If you have for example, a data set that may contain some variable that you're interested in for your environment, such as a water quality parameter like cadmium. And let's say you're interested in looking at cadmium across many different rivers in Canada. You can type in cadmium, and then you can get all the results from all of the rivers that may contain cadmium and present it in a readable sort of reporting type fashion that you can kind of dig into and get the data and do analytics with. And that's how we're envisioning NB Waters. Another interesting example of these cloud-based technologies is, of course, how Twitter is used by the CDC now. So the CDC, as you may be familiar who CDC is, are keeping track of various ailments that come up in the population every year, such as flus, coughs, fevers. And so they keep track of all of the people now that report into the hospital and tell the professionals that they're sick. And they compare it to the data that they have on Twitter, which, basically people are tweeting out there in the world that they have the flu or they have a cold, and the CDC now is mining all of this data. And what they're finding is 30, sometimes 40% more of the population are actually sick than the hospital administrators have been reporting in the past to CDC. Because most people that get a cold or a flu actually don't go to the hospital. And this is actually really starting to become very interesting for the medical professionals, not just in the U.S., but of course Canada and the rest of the world, because using social networks to track the spread of disease is a very important endeavor. This type of technology can be, once again, used with collecting environment data. For example, if we want to look at the health of a fish, such as benthic killifish, for instance, many scientific reports have been published on the health of the benthic killifish. If we had something like this that was being used in conjunction with data that's being collected on that fish by consulting companies, academics, industry, we would be able to have a better idea if the spread of disease and illness amongst that fish population is something that we should be concerned about. Another tools, of course, Gmail. I'm sure everybody saw those marketing ads that pop up on Gmail now. They're very specifically tailored towards you as the user. They're very, very specific. Something you may have searched for on Google. Next thing you know, you have a company presenting to you a solution in your Gmail, in a Gmail ad. Those types of things are all being done in the back end by cloud servers, and very large marketing data sets are being built not only by Google and Gmail, but also many, many, many other companies, big companies such as Walmart, Costco, even banks now are keeping track of what people are doing in their organizations, what their consumers are buying, and they're using that information to be able to present more goods and more marketing to the general public. And to me, this endeavor once again, makes me ask why are we so far behind in terms of our data being collected in the environment, and why don't we have these types of organizations for our sector? I continue to keep pressing upon folks both in government and industry that this is something that really needs to be considered in the future. Every day, many of us we make an unwillingly and unknowing we participate in the data collection that's been happening across the world by many different organizations. I think if we asked many of the folks on this call, if they were aware of how many organizations collected data on them today, they probably would know about 25% they'd be able to identify. So, how is it all possible? Well, it's all possible by cloud power. And so this is a buzzword that the tech industry came up with several years ago to really describe what a server mainframe is. And so a server mainframe sits out there somewhere in a data center, and the server mainframe presents data and collects data from many different devices. And those devices are all part of what we know as the cloud. This technology, now this is an image that was taken inside of one of Google's data centers. Each one of those racks represents a server. Each rack consists of about 20 servers, and so in this room alone, there's more than 10,000 servers. And so each one of these servers is a member of this Google Cloud, and this cloud just so happens to be what we know as the Gmail cloud. So, during my undergraduate, I had the idea that we should start building geodatabases and collecting data on the environment. So, what if all the data that we collected in this estuary could be then put somewhere in a data center like this? And then we would have the ability to be able to take that data and be able to analyze it and look for hotspots, environmental issues within a particular watershed. This particular watershed is a watershed in the Athabasca. This Athabasca watershed is something that we've been looking at for a number of years in Saskatchewan. And one of the things that strikes me about this particular watershed is that there's been a lot of data collected because it's in an area where we know that the oil sands industry exists in this area, and there's many industries that have been collecting data on this watershed. And basically what we've been trying to do in this and other watersheds within the oil sands is we've been trying to determine where hotspots and hot moments exist. And so a hotspot is basically a spatial difference between sites that we may see an elevated pollutant in the water, for instance, that's causing some degradation in the environment, and a hot spot is something that right now we still kind of struggle to figure out how we can take those data and put them into a data management system that all of the industries within the oil sands can have be easily accessible and also the provincial governments, for instance, to be able to access that information, and the federal government to be able to access that information. And that's something that we continue to this day to struggle with and determine how to address these issues. So what is normal in time and space? Well, that's something that we're looking to these large data sets to determine. So is there seasonal and annual differences? Is there spatial differences between rivers, basins, watersheds? Well, the question is, what is not normal? What's an exceedance? New data sets with exceedances, what does that look like? Based on seasons, within a watershed, how do we link these differences to stress? And are these stressors real, or is it something that's just within the natural variability? These types of questions are more easily answered if we have a large volume of data, because within that large volume of data, we can look within the data and see a trend faster. So we know that, for instance, I've got this particular data here circled. The cloud allows researchers and organizations that are concerned about the environment to examine these larger coordinated data sets more efficiently. And we can detect a problem within the watershed or within the river, within the population faster, because we have these large data sets that are accessible and more easily analyzed by researchers. Some of the past mistakes that I've observed, there's been no data standardization for many of the projects, both at the municipal, provincial, and the federal level. Data is often stored in its original formats. Custom processes are built to translate these individual data sets, which makes things fairly difficult to add new data, to fix problems or gaps that are in the current data. Oftentimes there's many thousands of duplicated units used. This makes it very difficult in terms of database analytics. There's no security, or there's too much security on these data. Poor storage formats is something I mentioned already, like Microsoft Access, Excel, even text files I've seen used. Poor geospatial layers, so the spatial layers are tied to on-site databases, which makes it very difficult to use in a remote environment or give to another organization to utilize. Expensive software is often required. So one of the things I've often seen is that government and medium-sized to big industry often use the most expensive geospatial software, and they often store all of their data in these formats, which makes it inaccessible to folks such as nonprofit groups, students even. These types of challenges are something that we need to continue to keep overcoming if we want to take data and make it available in an open, standardized format. Of course, other challenges such as inadequate funding, the inability to be able to host the data online, inadequate personnel, finding personnel with the skills to be able to take data from an organization and put that data on a network into a database, make it web accessible, provide accessibility to other organizations is a costly process for many. So I would like to propose that we develop a national guidance document for watersheds, and that they can put their existing data into the cloud for future access. And this is something that I've been working on with the Canadian Water Network now for the last year. And basically what we would like to see is this document provided to everybody. And so what we're looking to do is we're looking to put together a published open standard for collecting data, providing some tools and services, and making them freely available to organizations so they can collect and consume these data and take it and put it into the format that's required for us to be able to store it in the cloud. Data standardization is a really important topic. Now, this is a figure that I put together back about 2 years ago now. And this figure describes two different projects that I'd worked on. Both of them were really great projects, and both of them had a really great effort, and I was part of the engineering behind both of them. The first figure, so for project one, the first figure, you can see the different clouds with water written in different languages. And so those are non-standard data sets. What we do is we write a translation process, so we translate that particular language and we put it into a language that we can understand and all of the other clouds can understand. And then we process that data and we produce results from that data. And so that's one model. And that model had a lot of challenges, because one of the things that we experienced with that was that basically it forced us to do a lot of the work up front. And when we were forced to do all of the work up front in terms of translating the data, of course it required a great deal of time and effort and funding. And so what we realized was people really wanted to see the results faster. So in the second model, Project 2, we have, again, the non-standardized data set, water in different languages, and we translated the data once again, but then we processed that particular translation and we produced a result. And so we could produce results faster with this model. And this model, while it allows us to produce the results faster and produce reports faster, we're unable to cumulatively take all of the different data sets and put them together and produce a result unless we use Model 1 on top of that. And so these are sort of the two types of models that have been kicked around quite a bit in terms of translating data from an organization and putting it into, and that's when we are the ones doing the translation. So what I would like to do is I would like to have an open data standard that's followed by all of the organizations and agencies, and that open data standard can be shared amongst everybody. And as long as everybody is following the open data standard, we are then able to actually take as many data sets as we can that are similar in nature, collected similarly in nature, and put those data into the same database, a very large cloud-based database, which would allow us to be able to run analytics against those data, and we don't have to be the ones always doing the translation, because that's most of the projects in Canada that have tried that. Every one of them have burned out, and every one of them that I've been a part of have burned out. So security of the data is, of course, another important thing. I'm going to play devil's advocate a little bit here. So 2 months ago, I was in a closed-door meeting with a government official who made the statement that there's some data the public should know. This was a very telling statement to me from a government official. I was fairly concerned about that statement because the types of data that we were talking about at the time is data that is collected for the betterment of the public. And so this particular official felt that there were things in that data that could cause public alarm, and so that we don't have that data to put into our NB Waters platform, which is a very concerning thing for me. So my proposal went to the CWN. I asked them to mandate that all of the data that's collected from their watershed nodes be considered open source. And so if you have a watershed node that's out there collecting data that's being funded publicly, that data should be required to be open source, and anybody should be able to access that data. Well, that was a message that was met with very mixed emotions by folks. But at the same time, if this is an initiative that's not really considered something that's important, we're going to start running into the same types of issues in terms of being able to access the data. And the data being made publicly available certainly axes that problem. So by open sourcing data, we ensure that the data will be freely available for future generations. And by regulating all of the data be open source, we likely enhance data understanding. And of course, by providing the open source cloud, we encourage other agencies to follow suit, both nationally and internationally. So I've recommended, as I said, I've recommended that the water network start small with this particular proposal. And so I suggested that they consider picking one watershed, the St. John watershed as being the node to start with, and basically bringing the rest of the watersheds across Canada that are part of the Canadian Water Network into this model as we continue to grow it in St. John. A national standard for data entry, I think, is important to most of us, and it should be published and mandated. Adopting such a standard and staying with it ensures our success, even at the smallest scale. And developing guidance documentation for the collection of this data, and providing the tools to allow the data to be entered into the cloud in a common format, I think, is a really good initiative and something that most agencies are very, 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 very interested in. Developing these ease-of-use syncing applications, such as NB Waters, is something that I've been working on over the last couple of months. So developing a website application which provides the facility for anybody collecting environment-based data, providing the tools to be able to access that data in a web format. Also collecting things such as pictures, comments, and notes from the general public about these watersheds is another very important endeavor, which is part of the NB Waters platform. And don't require any expensive licensing or software to be able to use the application is another very important point for me. So what we do is we connect the water to the cloud. When we do that, we're able to generate results, and we're also able to educate the consumers of that application, and that is the goal. And so with that, I think I'll go ahead and turn it over to the questions. Michelle?
Michelle, are you there? Let me just see here.
Sorry, I was just getting unmuted.
Oh.
Okay, I can ask for. We've got one from Guillaume Dauphin. He says, "Thanks for your talk. I think this is definitely what the attitude toward data should be. I'm currently working at DFO, and I'm very familiar with data storage issues, i.e., security issues, poor referencing, data only available on one machine. Because things have been the way they are for so long, it seems to become the norm. And in order to make changes, one needs to make some administrative requests to be authorized to change things. If one had the authorization, then the issue is finding the time and resources to update all of the data sets and make them available to all. In the current economical situation and different budget cuts in government agencies, do you see any hope to make things better?"
That's a great question. In the current economic situation, well, I think we can look no further than our friends south of the border. During their worst economic crisis in many years, they continued to push forward with this type of effort. And we of course know that Obama has made big data his personal agenda. And we know that meant many things for many different people. I'm sure our guests have heard about the NSA by now. But another major initiative has been, of course, all the work that's been done by NOAA. And I'm intimately familiar with what NOAA's been doing in terms of collecting data across the United States. They manage a number of regional projects, and all of those data are collected and also put into a national cloud data server. They were able to do this during, of course, an economic downturn. And the beauty of cloud-based technology is, of course, if you are in an economic pinch, you can, of course, ratchet down the resources necessary to continue to be sustainable because it's all virtualized hardware. Unlike in the past, where machines were running as physical hardware, you needed a room of servers to run a cloud. Now you don't need that room of servers. You can have 2 or 3 fairly expensive servers, but You can control the amount of bandwidth, amount of power, all those types of things that are used by the service. If the economy is not supporting keeping everything up and running full speed. Another thing is, of course, security access to data that you'd mentioned, and this is a very important topic, and this is something that I think will continue to keep coming up as we start accumulating these larger and larger data sets. Certainly, foreign interests are very interested in these types of data, and our politicians are concerned about those foreign bodies, and so some of the publicly collected data isn't so public. It's actually not very publicly accessible. In fact, many people within their own organizations are not able to access those data. I don't know how that's going to change internally with these organizations. It's been my experience with environment ministries and Environment Canada and VFO, for instance, that these things move very slowly. So I don't know. There's a glimmer of hope, though, with Environment Canada. They have mandated that they're going to get out of the data hosting business, as they told me, and they're looking to make at least some of their major data sets publicly accessible, and they've been doing that actually. For instance, all of their hydrographic data should be publicly available now. They made their water quality data available. Not easy to find out there on the internet right now, but they have made these data sets available. And I think their hope is for private organizations such as, I'll use the Weather Network as a good example. The Weather Network has made a business on top of what Environment Canada and their meteorologists have been doing over the last 50 years. They consume Environment Canada's weather station data, and they've made a multi-billion-dollar business out of it. I think we can consider those types of opportunities, especially in the private sector, for publicly collected data, and encouraging governments, agencies to provide those data, I think, is paramount.
Okay, we've got a couple more questions. Guillaume says thanks. Okay, so from Elena Plummer, she says, can you provide a progress update on MB Waters?
Yes, so we would do these questions now, any general questions about this, and then we'll talk specifically about MB Waters.
Okay, she's got one more general one. Can you speak to how well data standardization processes have been received by groups wishing to contribute to this type of network? How have you or would you address the challenge of incorporating data of differing quality? So I guess there's two big questions there.
Okay. Actually, this is kind of an MB Waters related question, and so the way we've handled this with MB Waters is we've been looking at the ability for these lesser quality data sets to be part of our application. And so what we've done is we've identified basically creating several different databases. And so these databases are based on tiered access, if you will. And the folks that have access to the Environment Canada database, are not going to be the folks that are going to be putting data into the quote-unquote lesser quality data sets. But our facility and services that we're building allow the user to be able to upload those data as an individual, as part of an agency. And if you're part of an agency, the coordinator for the agency has control whether the data is made publicly accessible or it's kept private amongst the agency. So we're not only just thinking about public accessibility of the data, but if the agency feels that the quality of the data is not up to scratch, but they would still like to store it and keep it part of the database. This is something that the Brunswick Aquatic Data Warehouse has been doing for years. There's certainly many lesser quality data sets within that collection, as well as data that's been collected by these federal and provincial agencies. So I think it's still a great facility for anybody out there collecting data to be a part of.
And Elena says thank you.
Okay.
I have a quick question, if you don't mind,
Sure,
before we switch over. You had, in the presentation, you gave Microsoft Access Excel text files as being examples of poor data storage methods.
Yeah.
And I just wanted to ask you a little bit more about that. Are you talking about how the data should be entered before it's uploaded to the cloud? Or, I guess, do you have any recommendations about what sorts of software data should be entered in if those are examples of poor?
The programs themselves are not the problem. It's actually the way the data is stored, the formatting of the data in those programs is the problem. So basically, most folks like the spreadsheet paradigm, right? People like to store data in their spreadsheets, many columns of data. And this is a really big challenge for database administration and standardizing these types of data. That's one issue. Water quality data set, for instance, the USGS water quality data set is stored using the spreadsheet concept. And they have 228 columns of data in a single spreadsheet. Anybody that's analyzed data or has taken data and put it into a database following the modern database administrative techniques will know that's not how the data should be stored. And so this was a major challenge for us when we were working on the Threats project, and we developed several data templates. And so those data templates were used to build stored procedures that we then ran our spreadsheets through those stored procedures, which would then produce the data in the proper format for database storing. And so you get rid of those 228 columns of data, and you have one column. And then you have another column which has an identifier. That identifier is a unique ID number that represents the variable in which that data field contains. And so, for instance, if you had, let's say, dissolved oxygen, and its identifier was, the number 2. You would have your value in one field, and then you would have that identifier 2 representing dissolved oxygen. This makes it a lot easier for you to be able to also query the data, makes the system faster. It's how the social networking data also works. It's, form systems, whatnot. Look at something like how WordPress, for instance, works. The same nuts and bolts of those types of systems is what's being applied here.
So just to follow up on that, so what would you suggest for someone, say working in a watershed group, who wouldn't have access to a data engineer? And I mean, one of the reasons, yes.
That's a great question. And so what we're doing with MB Waters is we're actually going to provide the data templates that we've created and we've envisioned. These are what we're pushing. We're pushing these data templates to become an open standard when we launch MB Waters. So this is a big part of the project is to look at several different types of data that watershed groups collect on a regular basis. Water quality is of course a big one, biological health, fish health. These types of data that folks are collecting right now. And we've got a lot of samples from, we've got some Lakes Association, for instance. I just did a talk for them back in December and presented with them some work on Yoho Lake. Basically, these templates are pretty ubiquitous across many different types of data, and we certainly have once we've figured out the format and what's the data that's necessary to keep. We provide these templates, and if you follow the template and you upload the data to MB Waters, it can be entered into the the official database and will be made accessible as part of our reporting system. Now, if you don't want to do that, certainly you don't have to, and you can actually just upload it as a spreadsheet or an Access file, and indicate when you're uploading it that you don't want it uploaded to the geodatabase.
Great, thanks, Vince.
Yeah.
Okay, we've got another question here from Claire Herbert. She says, hi Vince, thank you for your presentation. It is good to know that there are other people/agencies looking to promote a standardized data method. Your statement about the Environment Canada data was very interesting, as we at the University of Manitoba recently obtained through an MOU, Memorandum of Understanding, a data portal, knowledge network hub developed by EC. The hub was designed with many of the concerns in mind that you've already stated, and as a way for the public, researchers and managers to access any information related to the Lake Winnipeg Basin, which includes 4 provinces and 4 U.S. states. We are aiming to standardize the data storing using SQL data warehousing architecture. We have based the metadata collection on FGDC and NAP standards. Have you utilized any of these standards in your templates? We would love to work with you more on this type of data management.
Yeah, we definitely have used the FGDC template, standardized templating. We've looked at a great deal of different templating methodologies. With regards to the hub that she had mentioned, the Water Knowledge Hub, is that the WE Hub that was developed in Alberta? If it was, an unfortunate piece of information about that hub was that it's been discontinued due to lack of funding.
Sorry, she says no, it's the lwbi.cc.umanitoba.ca hub.
Oh, okay, the Manitoba Hub. Sorry, I thought you'd said I thought you'd said the Water Hub, which is an application that I was familiar with. Yes, so we have followed a number of different standards. One of the things, though, that we found was getting too far into the technical with the non-technical folks has always been a major challenge. For me, like most of the folks that have these data sitting in on their workstations are, ecologists, environment folks, ecotoxicologists. 9 times out of 10, they kind of glaze over when you start talking about putting the data into a particular format and doing queries on it, and even just talking about pivot tables and Excel and stuff like that can sometimes be a daunting thing for people, which is understandable. It's not their area of profession. So what we've done is we've kind of dumbed down the level of standardization that the FGDC brings to the table for water quality data. The reason why is, of course, we want to make it as simple and as easy and efficient as possible for agencies to be able to get their data into the format that we need for MB Waters.
Okay, there's no more hands raised or questions right now. Claire says thanks.
Cool. Okay, so let's just see here if I can get my screen to share.
Yeah, we see it.
Okay, great.
Yep.
So you can see the web browser now. I have 2 screens here, so I just need to make sure you see the right screen.
Yep, we see we see the correct screen. Yep.
Okay, so this is NB Waters as it currently exists. Here we have the home page. And so the way we're building NB Waters is essentially we're looking at two major user groups. One of them is, of course, the researchers and project managers and those types of more official agencies that will be interested in using the application. But then we're also looking at the public as well, and so we're thinking the public is going to be very interested in utilizing this particular service, and so we've been looking at other applications out there like the Weather Network in terms of the types of things they do to entice the general public to get interested in this type of initiative. So right now we have a map here on the home page. This is a very early development version of the website. Right now we're looking at a launch of NB Waters sometime in the early/late spring. April is looking like a likelihood of the launch month. And so what we're looking at doing with NB Waters is getting users to use the website, not just agencies and organizations, but also general users. And so here on the home page we have the waterways, and you can see we have a parenthesis with a comment. So somebody made a comment at this particular river, and if we go ahead and click that, it'll go ahead and take us to the page which contains all the information about that particular river. The individual was there, and there's the comment that he had made. This guy presented us with a photo of an eel he had caught. We're encouraging people to discuss the various rivers and water bodies in New Brunswick, post pictures, data even, whatever they want with regards to that particular water body. So really encouraging people to come out and tell us a little bit about that particular water body that they're currently experiencing. So we want the general public to really take advantage of this service, and I think people are going to really like it once we start marketing it to the general public. I can definitely see lots of photos getting posted here. We're really playing on the social networking aspect of things too. And when information comes into NB Waters like this, we also syndicate it, and it goes out to our social media feed. So it'll go out to Facebook and as well as Twitter. And we'll let people have some fun with that. On the more serious side of NB Waters, for our maps right now, we have just over 50 maps generated for the province of New Brunswick based on the data provided to us from the New Brunswick Environment, Natural Resources, the university. Also, several private industries have provided data to us. For a simple search and categorization of the data. So we have community aquatic data set. We can see this. If we click it, you can bring up the map. Here we have the data that's available for this particular community. We have aquatic site ID. If you click that, it actually will take you to all the data that was used to generate that data point. And you continue to kind of keep clicking through. Some of these data look like this. Some of them look like reports. I'll show you one that has some reports or hydrographic data. This is our hydrographic map. So these are all the hydrographic stations across New Brunswick. So we click this one here in Minto. We have the station number. We click the station number. This is some basic metadata about the station. We click that, and here we have the mean annual level of water across from 1965 to 2008 for that particular station in Minto. So that's another example. Let's just see here. Electrofishing might be an interesting one. So this is our electrofishing map that we created from data provided by Department of Natural Resources. Go ahead and click one here. Will take us to this electrofishing site. And so here we have all the data collected from various fish that were collected. So all of these data will actually be exportable. So you'll be able to export all the reporting type data that we give off of all of our maps into a spreadsheet. So you can take away and do with whatever you would like. Let's see here. We have water quality. Of course, we've got some water quality examples as well. So here's all of our water quality stations in the province of New Brunswick again. This is data that goes to the Environment Canada database that I mentioned during the talk. Same sort of mechanism again. Let's go ahead and pick something like dissolved oxygen. We analyze the data, and then we get the dissolved oxygen. This is providing some mean annual dissolved oxygen. And you can also go ahead and export or print the figure. Okay, so those are some map examples. We've got lots of great maps that have been generated, and every day we're making more maps. You'll also see there's a number of buttons on our maps page. So we give you a web mapping service, a comma-separated file, a shape file for you can go ahead and click this, and it will go ahead and download the shape file. And you can open that up in your ArcMap and use the service that way. A Google KML, so you can use it with Google Earth. Even an SVG file, which is a vector graphic file, and a JSON link. So with JSON, you can actually go ahead and use this to consume the data in an application. So if you have a web application, for instance. So for our apps, we're also building a number of different applications for NB Waters. We're currently working on an Anglers application. Unfortunately, I can't show you guys this application today. We're also working on a community water quality application. All of these different applications are very much so in active development right now. We're really excited about being able to provide applications. Right now these are all web-based, but they're being built using HTML5, and we're planning on providing a mobile accessible version, so you'll be able to get it on your tablets and your smartphones as well. We're also collaborating right now with an organization at the University of Maine, and we're looking at bringing in even more data south of the border from the University of Maine to be included as part of these applications. So we're quite excited by that. We're also working with Environment Canada to build a Gulf of Maine, Gulf of Maine application for the Bay of Fundy region, and that application should be available when we launch in April as well. In terms of publishing data, right now we have a fairly simple mechanism. All you need to do is in order to be able to use this publishing application is basically you need your data in that standard format. And so when you go ahead and you say, okay, I've got some water quality data that I need to upload, we say, okay, here's the template. You can download the water quality lakes template, and you can look at that template, determine how the data should be organized when you upload it. When you click an existing upload, this is an example of a data set that was uploaded. This is data from the Yoho Lakes Monitoring Program by the New Brunswick Lakes Association. Here you can see we've got data from the different sites at that particular lake, and here's the data presented in the readable format. We also let you be able to do some geospatial tools, as well as printing the data and saving the data out. So you can save the data to your desktop and use data from these particular stations. The types of data that we're looking at collecting, these are the types of categories right now. This will be all updated when we launch. More categories added. Some of these will change a little bit, but just to kind of give you guys a breadth of what's going into NB Waters and how it's starting to shape up. I also talked during the talk about Dropbox in terms of revisioning the data, and that's something that we're actually doing with NB Waters. In the NB Waters cloud, we actually are keeping revisions of the data. So if you upload a data set, for instance, you want to go back and look at an older data set, you know, let's say your cat jumped on the keyboard or something and deleted the whole row of data and you didn't realize, you can go back and get that revision of data. Well, I think that's about it for the data aspect of it. Some other things that we are doing as well is we're also providing some API access to NB Waters, so we're hoping other developers will come in and want to take part with that. And yeah, I think that's a pretty good overview of where we are at with NB Waters. So I'd love to take questions about this.